Okay, let's look at problem 2. So we have a random sample of 64. That's n is 64. And a sample mean, that's x bar of 9.52. And a sample standard deviation of $2.40. Because it's a sample standard deviation, we're going to have S, and that's going to mean that we have to use the t-table. Okay, so we have enough evidence to conclude that the population mean is less than 10. So the research hypothesis is mu less than 10, while HO is mu equal to 10 or mu greater than or equal to 10. Now we want to evaluate those hypotheses using the critical value approach. We're going to reject HO if the t-test is less than minus 2.387. If it's less than in the research hypothesis, it's less than minus in the decision rule. Quite a few people missed that on the test and just said less than 2.387. Remember, it's less than minus 2.387 because we're going to go below the mean. So our standard error is the sample standard deviation divided by the square root of n. That comes out to be 0.3. And our test statistic, t-test, is the sample mean minus the hypothesized population mean over the standard error. And that's 9.52 minus 10 over 0.3 is minus 1.6. So that means that the 952 is 1.6 standard errors below the mean, below the hypothesized mean. And that is not less than 2.387, so we fail to reject HO. And we conclude that the population mean could be 10. It's plausible. We won't say we're confident or anything like that. It's plausible. The reason we say could, and that we don't express any confidence, is we don't have a clear estimate of error, like we would when we reject HO. When we reject HO, the error is that level of significance, in this case 0.01. So now we're going to construct the 98% confidence interval, the statistic, plus or minus the confidence coefficient, which is t in this case, since we have a sample standard deviation, times the standard error. So we got 9.52 plus or minus the 2.387 times 0.3. Now that 2.387, that's a confidence coefficient, and confidence coefficients always come out of the table. So this is the same thing we used as the critical value. Look under 98% confidence and 63 degrees of freedom on your t-table, and you'll get the 2.387. Quite a few people on this one put the 1.6 that they had calculated in the first part, but this is from the t-table. Anyway, there's our calculation, 8.8 to 10.24. So now we're going to evaluate the confidence interval in practical terms. We're just going to say that we can be confident, 98% confident to be specific, that the population mean is between 8.8 and 10.24. So for more theoretical explanation, this means is if we constructed many, well really all possible confidence intervals that we could construct from the population, 98% of those intervals would include the real population mean. At the same time, 2% of those intervals would not include the population mean. So what we have is confidence, not certainty. We know right up front that we can and sometimes will be incorrect. In fact, in this case, we know we'll be incorrect 2% of the time. And we'll make the wrong decision if we want to say that the population mean is in this interval. It simply won't be the case 2% of the time. Of course, we can change that by having a 99 or 99.7% confidence interval or whatever. In this case, we have a 98% confidence level. Our confidence interval will include the population mean 98% of the time if we did this over and over and over again. But 2% of the time, we would construct an interval that would not include the population mean anywhere in the interval. So the other questions we had were, is the sample size large enough? Where the sample size was 64. So the answer is maybe. It depends on whether or not there were extreme values. Remember, We can have outliers because our sample size is greater than 40, but it's not greater than 100, so we can't have extreme values. Also asked you, just as part of a review from the last test, to identify each of the following for this problem. An element then is just a concert ticket, one concert ticket purchased online. And the variable is the incidental charges in dollars and cents. It's not the price of the ticket because it's just asking about the incidental charges, like tax, parking, handling fees, and that kind of thing. Maybe you can tell I bought a ticket for my daughter to a concert last week and there were all these incidental fees.